So section 12.1, this is one where we construct several graphs. So we've got the stem and leaf plot, and you should see the stems go in order from smallest to largest. We say in ascending order. Same thing for the leaves coming out this way. You should have a title, and then you should also have a legend that describes what each one of the numbers means. The legend is important, as you can see in this one here. You might think that this data value right here is 40. But when you look at the legend, 1 and then the vertical line and then 4 means 1.4. So this is actually 4.0. And so here's what the data values would be. You actually have a decimal point between each one of the stem and the leaves. I didn't draw the graphs down here, but I did do the frequency the frequency distribution. The distribution is the table, and so here they want the frequency distribution and the relative frequency distribution. So I just put them in one table. So you take the frequency, and then if you divide by the total, and then you convert it into a decimal, you'll get this number here, 0.118. And then if you, the reason we convert it to a decimal like this is because then it's easier to convert it to a percentage over here. So 0.118, 11.8, 0.216, 21.6, and so on. And then a couple of misleading graphs. In this first one, you've got these 3D boxes, and it makes the average salary, which I think these numbers are, 74,602. It makes this amount look much bigger than this number down here. If you take 74,000 and divide by 18,000, you're going to get something close to 2. I mean, you're going to get something close to, what is it, 4? Yes, something close to 4. And if you took 4 of those boxes, there's no way that 4 of those little boxes would total this big box. So these look out of whack. What probably the person that created this graph wants you to see is that, you know, you make a dramatically lot more money if you have an advanced degree. The more education you make, the more your income is. And they wanted to illustrate that, but in the process, they got to a graph that's misleading. This next one, adoptions from China. And when you first glance at this, and you see this is the year 2000 and this is the year 2005, it looks like the number of adoptions from China has grown dramatically. In fact, this bar here might be 3 times as large as or tall as this one. So you might think that there's 3 times as many adoptions in 2005 than in 2000. But it turns out that if you look over at the scale here, in 2000, there were 5,000 adoptions, and in 2005, there were about 7,000 adoptions. And the reason why it looks so lopsided here, looks like there's so many more in 2005, is because this axis doesn't begin at 0. Whenever you start at a number other than 0, there's a possibility that the graph will be misleading. And so just to show you that, I drew the same graph, 5,000 here and 7,000 there, but with a new y-axis scale that starts at 0. You can still see that there's a dramatic increase from 2000 to 2005, but it's not as dramatic as this one over here. And the last graph here, also misleading. It has the same problem as the previous example where it didn't start at 0. So these bars might look more different than they really are. The other thing is that this one's misleading because, you know, the VW Passat, it has the smallest bar, and usually we associate smaller with slower. And this is all about the speed of these vehicles. And if you look over here, it's time to accelerate. And if it takes less time to accelerate from 0 to 60, that must mean the car is actually quicker, faster. And so we probably want to put a different unit over here on the vertical scale so that bigger bars mean faster and slower cars have smaller bars, but that's not how it appears here. So this graph and all three of these graphs, while accurate, they're somewhat misleading because of the way that they've been constructed.